Let's do a basic example. We go before I give you some more points to consider and then some more examples. So here we have an integral of something on the form x times e to the 2x. You may want to try to see if any substitution, any change of variable might help solve that integral. And no, it will not. But as always, you may want to try it just to see why it does not. Okay, so what we're going to do is we're going to choose which of the two variables we're going to consider as derivative and which one we're going to consider as the original function to differentiate. Okay, so the choice I'm going to make is this one, and you may wonder, why did I choose it this way? Well, notice that g of x is an easy function to differentiate. In fact, once we differentiate it, we end up with 1, which pretty much tells us that we get rid of the x, and f prime is also easy to integrate with a simple substitution. Okay, so what we're going to do is we're always going to choose our f prime and our g, so that f prime is easy to integrate and g is easy to differentiate. Now in this case you might wonder, well, g is also easy to integrate and f prime, the e to the 2x, is also easy to differentiate, so why didn't we pick the other order? Why didn't we pick them in the other way? Again, I'll leave it up to you to discover it on your own. Make the other choice. Choose x as f prime and e to the 2x as g. You'll notice that computing the derivative and the integral and the antiderivative will be easy, but what you come up with is not going to be very fun to work with. In fact, it's not going to be any easier than what we have right now. So that's the reason why I chose it that way. How do I know that that's the right choice? Experience. So try to start building up your own experience to so that you're able to make that choice wisely as well. So if f prime is e to the 2x, what is f? Moment of pause for you to think about it, and yes, it is e to the 2x over 2. And so if g of x is equal to x, how much is g prime? Well, obviously, duh, is going to be equal to 1. All right, so that's the formula we want to use. Let's see if it's going to work out. So in our case, the formula we're starting from is x e to the 2x dx. So how much is f times g? Well, f and g are those two functions, so the product of them is going to be x e to the 2x over 2. Now we're going to have to look at the integral of g prime f. Well, we have there g prime f in front of us, so we're going to have to compute the integral of 1/2, well, that 2 can come out of the integral, times e to the 2x times 1. Well, that's easy. Now we know how to integrate e to the 2x, right? So we can just do it and we get our solution. So this shows you how the process works. We chose our g and our f prime. We basically reversed the role of the two, came up with an easier integral, and then we use that to arrive at the final answer. Final answer? What's missing? Come on, what's missing? What's missing? Yes, you're right, the plus c. Okay, don't forget to use the plus c ever. A few points to consider about this method as well, just like we did for the method of change of variable. Well, first of all, this only works if the new integrand is easier. Okay, remember that we're switching from the original integrand, which is a product of two pieces, to a different one, which is also a product of two pieces, but where we have reversed the derivative and the antiderivative. If that new product is not any easier to integrate, then we're stuck. The method doesn't work. Well, sometimes it's not essential that the new integrand be easier, but at least it shouldn't be any more difficult than the one that we started from. Otherwise, there is no point. We're just making our life more complicated. The other thing is that often there is a choice, again, as we have seen in the previous example, of what to pick as g and what to pick as f prime. So what you may want to do, just like you did for the method of change of variable, try each of them before giving up. If the first choice of g and f prime doesn't work, try a new one. Another thing to do, to always keep in mind, and this is true for any integration method and any application of integration method, is always check your final answer by differentiating it. One minor thing here that I want to also mention verbally at least, some of you may have seen the method of integration by part presented in a different notation, with the notation of integral of u dv is equal to uv minus integral of v du. That looks much more like a linear algebra thing where we have u and v v as vectors, but they're not. Anyway, if you are used to that kind of notation and if you're comfortable with it, by all means keep using it. I will be using this particular notation because I like it, but it doesn't mean the other one is bad. It's just not my favorite. So feel free to use whatever notation you feel comfortable with, as long as it's a proper notation, it works and is commonly understood.